Do you have children who love playing with perler beads and creating such wonderful shapes? How do you go from a colorful mix of perler beads to such a state? I was tired of wasting so much time sorting the beads. I wanted to try to build a sorting machine. Here is my result. I've linked the schematics, program code, node red flow, and 3D printed parts in the video description. The core of the machine consists of an ESP32 microcontroller, a color sensor, and 2 stepper motors. The motors are controlled with the really cool TMC 2209 driver stages. In addition, 2 sensors are installed that can detect the position of the 2 rotating plates. That's almost everything. The rest is to come up with a suitable mechanical design, which was one of the toughest tasks. Also to write the code for the controller, conduct test runs and analyses, and ultimately have a fully functioning sorting machine. For tasks like this, where individual pieces have to be filtered out of bulk material, you need a separator. I do this with a rotating disc that is set up at an angle. The beads are taken out of a small volume, into which the beads can be poured, using 16 holes. The bead falls into the hole and is picked up, and this is where the first problem begins. The bead is either lying or standing in the hole, and is therefore of different brightness when illuminated. If the bead is upright, there is also a hole in the middle, making it more difficult for the color sensor to detect the bead. I created the rotating disc with a 3D print. Unfortunately, the axis of this disc is never completely at right angles, so the disc rises slightly when rotating. This in turn causes problems with color recognition. The best method for me was to calibrate the color values with empty holes at the beginning to determine and save the values for each of the 16 individual holes. At the beginning of the project, I wanted to use a self-learning program to automatically detect the dominant colors, but that was too imprecise, and I ended up with a method where all colors are recorded in a test run. Then in a second step, determine the values of RGB. It is important to convert the values from the RGB color space to the HSV color space. This makes it easier to differentiate. In my case, I have 9 colors that I have scanned and displayed in Excel. I calculated the maximum and minimum HSV values and used them to feed the if-else loops in the ESP32 code. In order to monitor the values better, I use a node red dashboard in which I can display the 16 calibration values and the current detected color values. Node red also makes it very easy to carry out a test run with just one color, for example, and save the values in a file. The containers for catching the beads are printed with transparent filament, so you can see what color they contain. I actually wanted to develop the PCB with KiCad and then have a service provider create a layout, but in the end it just turned out to be a breadboard with wiring on the bottom. Sometimes 2 beads get stuck, causing the disc to lock. In this case, recalibration is necessary. This could also be improved by automatically determining the position in real time after each rotation and correcting it if necessary. If you like this cool machine, please subscribe to the channel. I definitely plan to add more content of other projects in the coming months and years. You can find all the files and the source code in my Google Drive.